And I'm muted. All right. Hey, everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your Weekly Space Hangout for Friday, May 9th, 2014. Joining me this week, the Planetary Society has sent us Casey Dreier with good news.
Hey, Fraser.
Hey, Casey. All right. Morgan Rehnberg from Cosmic Chatter. Hey, Morgan.
Hey, Fraser.
And some other guy, Scott Lewis.
Just some guy, you know.
Just some guy I know. This guy I know named Scott Lewis.
How's it going?
Good. So this week, it's going to be a ragtag collection of stories. We're going to have, a really cool simulation of the entire universe, which is awesome.
All of the universe?
A review of Cosmos, which I've seen this week, so I can speak intelligently about it. Plants going to Mars. A new Earthrise photo. Perhaps this event that Scott's doing called One Sky. And then good news from Casey Dreier about money for space exploration. So, where do I want to start? You know what? I think the big news is this crazy simulation of the entire universe. So Morgan, what's the story on this?
Right. So, well, first off, the story isn't a simulation of the whole universe because, as we'll see, too difficult. We've actually simulated about 1/10,000,000th of the universe using sort of a new state-of-the-art method for starting back near the Big Bang and advancing the evolution of the universe through the last 14 billion or so years.
But can't they just copy-paste another billion times?
It gets out of hand pretty quickly. So they ran this on the fastest supercomputers in the world, which is about the equivalent of putting together about 8,000 of the fastest computers that you could go out and buy today. And it still took them 3 months to compute 1/10,000,000th of the universe. And they claim that if you tried to run their simulation on your home laptop or desktop or what have you, it would take more than 2,000 years for you to advance this one tiny piece of the universe all the way forward to today, and then looking forward into what might be our future.
Maybe they should just use the Bitcoin network instead. I think that would
Or
get
I
it
think
done.
it's deep thought. Deep thought would really help with this.
Yeah, exactly.
Well, but we don't have to compute the whole universe in order to understand a lot about it using a simulation like this. Because one of the nifty things about the universe is that when you look at the right scale, the universe actually looks about the same no matter what direction you're looking in. And that's one of the hints that we're not special and in the center of the universe. We're just kind of out there in the burbs with everybody else. And you look left, you look right, you look up, you look down, universe looks about the same. So if we can simulate one chunk of that universe, we can apply the knowledge that we gain from that to all the other parts.
I'm going to ask you a bunch of questions in a second. I forgot to mention that you can interact with us using the Q&A app. So if you want, just go ahead and enable that wherever you're watching this on YouTube, and you'll see a list of all the comments and questions, and feel free to jump in with some stuff. Okay, cool. So Morgan's put up a picture of the entire universe.
All right, so one of the cool things about a simulation like this is it lets you see more than we can see with a normal telescope. So what we're looking at here is part of their simulation. But what we're seeing is more than just the stars. We're also seeing the gas that's out there in the universe, and that's actually rather difficult to pick up with a telescope. And we're also seeing, you can see all of those blue filament-looking structures. That's the dark matter that the simulation suggests runs through the universe and kind of binds together the galaxies. And of course, dark matter, by its nature, is something that we'll never be able to see directly with a telescope. And so with a simulation like this, we can get an understanding, or hope to get an understanding, of how these things are combined in ways that we wouldn't otherwise be able to do.
But what's that sort of bright yellowish, orangish part in the middle?
All right, so this picture is not like showing you what you'd see with a telescope. The colors, I think, here represent temperature. And so this is, hot gas surrounding a galaxy that you would find here in the center of this. And then that galaxy is surrounded by these filaments of dark matter that we commonly call the cosmic web.
Because people are just going to look at that and just say, so that's where the Big Bang happened.
Right.
And that's going to be
those
really
are where my hopes and dreams go.
Right. So we can
go to die.
What we can do is we can decompose that into something like this. And this shows you those 4 different pictures, that shows you that same image broken into the 4 different channels. So on the left there, you can see the dark matter. That's the spindly structure. In the second one, you can see the density of the gas in the universe. This is hydrogen and helium gas. And you can see that that gas tends to collect along those spindles of the cosmic web formed by the dark matter. And then, you can see that each of these separate frames represents some different piece of information. And of course, as a scientist, you're going to want to break this down as much as possible and not just look at the one big, pretty picture.
Awesome. So what does this mean? Do we need to run a bigger simulation?
Well, so this is already the best simulation that we've done, and we're just going to start.
I'm bored of it already, though.
We're just starting to sort of understand what it could mean for us. So how do we test something like this? Like, how do we know that they simulated it right? Because this didn't just form the Milky Way. Because without exactly perfectly setting up the universe and running that simulation with infinitely good precision, you're never going to get the actual results of the universe we see. But we can test our observations against what the simulation suggests. And for example, this simulation produces the right mixture of elliptical galaxies versus spiral galaxies. And in those galaxies, it produces the right chemistry of the stars in those galaxies equal to what we see in galaxies of those kinds out there in the universe with observation. And so what this lets us do is, if we can match up say a Hubble image of an object out in the universe with something in this simulation, then with the simulation we can kind of run time backwards and see how that Hubble object might have formed. Because that we can piece that picture together by looking at different objects at different stages of their evolution in the sky, but we can't look at one object over the course of its lifetime. And that's what this simulation will let us do, is get a sense of, what does a single spiral galaxy look like over, its 5 or 10 billion year lifetime.
But you can just imagine more and more powerful simulations, more computers.
Oh, absolutely. It's only going to get better.
It's only going to get better, yeah.
But I would imagine that we'll focus more on increasing the fidelity of the simulation before we would increase the amount we were simulating. Because this simulation cube was already 35 million light years on a side. And for scale, the Earth, or the Milky Way, is about 100,000 light years across. So we're talking about a space to hold many, many galaxies.
Hugo Burnham asks a great question, which is, have they run the universe simulation forward by 10 to the power of 45 years? And if so, what happens to the universe?
I think that they've, at this point, only basically brought it up to the modern day, the present time. Or at least that's what they've unveiled so far. And
it gets too
once
depressing
they
to do
know,
that into the future.
Yeah, once they know that it works that up till now, then maybe we can start peeking at the near future. But going that far forward probably is going to break down assumptions made in the simulation about various physical parameters and things like that.
So it just shows a big brain in a jar, and then game over.
A floating baby.
That's all we are.
Elad Avron asks, do we know that the cosmic web is made of dark matter? Do we even know enough about it to represent it in the simulation?
Well, so yes and no. We have an idea of how much dark matter there is in the universe. And we know that the cosmic web exists because if you do nothing but plot up the positions of the galaxies on the largest possible scales, you can see that web structure, because every galaxy seems to be surrounded by this kind of halo of dark matter. But in terms of understanding, the exact distribution of dark matter in those strands versus surrounding galaxies, I would say that there's not sufficient observational evidence at this point to really give us a constraint on that. And this is what theorists and modelers just love, because now we can make a whole new generation of predictions that then give us something to go out with telescopes like Hubble or James Webb or Keck and actually test going forward.
Sweet. I love this idea, that we don't know what dark matter is, but we can use it as a telescope. We can use it to probe further back into the cosmos. We can use it to map out the locations of chunks of matter.
That's,
You know,
that's my favorite thing that we're doing with Hubble right now is we're using dark matter for the Frontier Field mission is gravitational lenses to look further back than Hubble was ever designed to do in the first place.
yeah.
Just because we added on the infrared detector on there, now we're able to use that dark matter because it's achromatic. It does not affect the light. It just warps the space time, and so we're actually just able to use this thing that we know very little about, but we can still use it and study it in the process of.
It's remarkable how quickly it's been adopted by the scientific community.
We don't know what it is, but it makes
We
a
know
great
it's there,
telescope.
but we don't know what it is.
It's made out of telescope. All right, so let's move on. All right, Casey, hit us with the news.
I was
The
going to
good
say,
news.
personally, my absolutely subjective opinion, this was the most important news this week in space. So, I mean, obviously, usually I'm always coming here doom and gloom about NASA's getting cut, this mission's getting cut, this mission's getting cut. And this week, this is why I have such a big smile on my face. I just got back from Washington, D.C. yesterday. I was out on the Hill all last week with Bill Nye and the Planetary Society's consultant going around to congressional members talking about space. And what did the House do? The House of Representatives passed their part of their budget. So they break the budget down into 12 chunks. Each subcommittee gets a chunk. The subcommittee that works on NASA said, oh, by the way, NASA, would you like an extra $430 million this year? And they actually increased NASA's budget above the president's request for 2015 by almost $500 million. Wow. That just hasn't happened recently, particularly House of Representatives, not really known for giving extra money to things, but they're prioritizing, and it wasn't just NASA, I should say, the National Science Foundation got an increase of $200 million as well. The NOAA got an increase of $200 million. That, you know, it's a weird thing in this country. There are still parts of bipartisan support. NASA and NSF can be areas of bipartisan agreement, and the House Republicans gave extra money to both of these agencies.
Well,
within NASA,
isn't scientific progress one of the greatest challenges and greatest requirements of kind of any nation at this point? Like,
absolutely.
It seems like a no-brainer to put more money into science to advance your science.
I agree. You know, that's weird, Fraser. I think we're in complete agreement on this. It is, and I think politicians are starting to really see that you have to invest somewhat in the. I mean, again, we're still talking about fractional percentages of the total national budget invested in basically research and development and science and new technologies. But they've upped the pie a little bit, and this changes the whole dynamic because a lot of the times, you know, planetary science, what the Planetary Society has been really worried about, they've been cut over the last few years, and because the whole pie just grew a little bigger, you could add more money. So they actually upped planetary science almost back to its historical level. They're giving it $1.45 billion a year. Our goal for the last 3 years has been 1.5. So we're within $50 million of this very important restoration to planetary science. It increases, they actually put money back to run the SOFIA flying infrared telescope. They have money for, they upped the level that the House gave for commercial crew, more money to the SLS, more money to Orion. It's generally just a very, there's a few small things, but generally it's a really great budget for NASA, and that's because they just increased the pie a little bit. So, you know, so here's where, just to throw a little bit of cold water on where we are, this is just kind of the beginning of this whole budget process. So the way it usually works is that the president releases his kind of original proposal back in March. The House and the Senate both kind of start working on that in subcommittees and then up to committees and then up to the full House, and then the Senate does the same thing. They work on the subcommittee, pass it up to the full committee, full Senate to approve the full federal budget, and then both of these things have to come together, and then they do this thing called a conference committee where they argue behind closed doors about what the priorities are, restore that back out to both House and Senate, and if those are proposed, those pass both chambers, then you have a budget. So what we're at is that this is the first step by the House. The House has said, here's our idea for what NASA gets next year, and we want to add $500 million to NASA. The Senate hasn't gone that far yet. They just had their first hearings on the NASA budget. We're thinking within the next few weeks we'll see their idea of what NASA should be. Luckily, NASA has a very strong supporter in the Senate, Barbara Mikulski from Maryland, who has already stated that she wants NASA's budget to increase at least to last year's level and more if she can. So that the House, the Republican House, added money to NASA gives her great political cover to say, great, look, we have bipartisan, bicameral support, let's get some money back. So we're in the first step of this process. It's not going to be done until the fall, hopefully. You know, as you've noticed recently, the government has had problems passing budgets lately. But the initial conditions for NASA, and particularly for smaller sections like Planetary Science, those tend to kind of just flow through. And that's just very, very exciting. And I have to say that this is what happens when you start building this really consistent, involved, what I call constituency for space. People who we're getting noisier, we're getting more aggressive, and we're staying focused not just budget season, but year-round, going to Congress, going to NASA, and arguing for the same message over and over again, is that you want a good space program, it's got to grow somewhat. You can't keep cutting it like this.
Yeah.
I actually have, if I can do a quick screen share here. Yeah, go ahead. Well,
I was just going to say that, you know, I mean, what a lot of these programs really require is consistency. I mean, if you gather together a team of people and they're going to scope out and start building the Europa mission, and then you cut all of their funding, they have to then reassemble themselves into other projects or potentially go and work, you know, they may have to go back to aerospace or computers or whatever. And so you'll, you know, then if the funding is restored, then you're going to have to bring the people back who can come back. You're going to have to you know, you're going to have to staff up new people, and you lose so much momentum. So I think that this kind of up and down is a real killer for these kinds of long-term projects.
I agree, because
that's absolutely true.
What you're doing there,
and while I have the...
Go ahead, Casey.
Oh, okay. First, let me just say, here's the picture of actually, I was with Bill Nye on the Hill. This is our physical petitions from members of the Planetary Society. We dropped off of over 5,000 mailed petitions by hand last week, and then we've also delivered over 40,000 additional online emails, petitions, and numerous phone calls directly to offices. So it's part of our real just focused attack on planetary science, but also NASA funding in general.
I mean,
kudos to you were saying.
Guys. Yeah, well, kudos to you guys with the Planetary Society for really doing a good job on being on the internet about all the social media and all this kind of networking. That you guys have made a really good transition from the old, like, it must have been so tough in the olden days with telephones and writing letters and that kind of thing, and now you can summon angry bees at a moment's notice when needed.
That's absolutely true. Back in 1980, when actually the planetary division of NASA literally was almost completely canceled, the Planetary Society was the very first year of our existence. We got something like 10,000 people to write letters to the White House to support this program, and the White House didn't even know what to do with this back then because no one had ever really written in a consistent way about NASA, and they actually forwarded all those letters unopened to NASA, so it just did no good. But now it's totally different. We know exactly the points where we're hitting, and as you said, we can rally people. We don't have to, like, send telegram. That's how they used to do it, and they had to send a telegram to get there right away. This is pre-fax. Now you can send fax, now you can send emails, but then the crucial thing is, and this is why we have this whole roundabout program, is that, you know, people, you don't just send a petition off into the void. We walk into that offices, and we have all the data now. We say, look, you've just received 5,000 petitions about planetary science and NASA funding in the last 3 weeks in your district. This is important to your constituents, and then we can follow up and really hammer that point home. And again, I think we're really starting to see the consequences of this with not just the increased planetary funding, but the increased funding for NASA in general, the increased funding for NASA science, and just that realization that if this country wants to maintain the space program, it's got to at least let it grow with inflation and just give it a little bit. It's trying to do so much that we're really, really exciting benefits here. So again, we talked to senators last week. We talked to Dianne Feinstein, who's on that subcommittee that appropriates money to NASA. We talked to Ed Markey, who's in Massachusetts. We talked to Bill Nelson, of course. He's a big supporter of NASA, obviously. He flew in space back in the 80s. And we also met various people in the House. So and again, our message is the same. People really respond to that. And again, I think this whole thing with what the House has done is really a game changer in terms of our argument about NASA funding. Now it's not just where's the money going to come from. Now the argument is like you can just grow the pie just a little bigger, and you can really see some huge differences.
Well,
and
could you pass along my... Oh, go ahead.
Well, I should say that one of the big things that we're also working for, as part of the reason why we want the planetary budget to increase, is the mission to Europa. And you guys have talked about this a lot. A lot of your people watching this now know last year they discovered those plumes spewing out of the South Pole of Europa, which I think just really changed this whole conversation about why and what we're able to do. JPL has this reduced cost mission called the Clipper, about $2 billion. It's like the low end of a major scientific mission, where instead of orbiting Europa, you can actually just fly by it, kind of like Cassini has flown by Titan at 40 times. And you can actually do a lot of the same science in terms of determining the thickness of the ice shell, determining how big that ocean is and to the extent, things that they think they know, but we really need to confirm, mapping out the surface in 3D, really high-resolution photography, which would just be beautiful. And now they say, because they know that there are these plumes there, they think there are these plumes there, they can add a little mass spectrometer onto that mission. You can fly through those plumes, and suddenly you can start looking for a lot of these organic molecules or whatever chemistry in that water that was previously the purview of penetrators and submersibles and these really far-out technologies. And so this Europa mission, that we've been pushing this really hard this year because, I mean, obviously people love Europa. It's one of the most compelling destinations for astrobiology in our solar system. We have the plumes now. We have a plan. It's highly ranked by the scientific community, and there is a huge fan. I have to say, I have not met a bigger fan of a mission to Europa than Representative John Culberson from Texas. He loves Europa, and he's on one of the House appropriations. He gives money to NASA. He says, I want in my lifetime to see a submersible in Europa, like swimming around looking for hot smokers in Europa. That is a great person to have on our side, and just shows the extent of the bipartisan, bicameral kind of support that NASA still can get.
Very cool. Well, and I was just going to say, have you passed along my idea of separating the budget between manned human space exploration and planetary science and just science in general, so they don't have to fight?
Well, that's the thing. That when the pie grows bigger, everybody kind of wins. And so one of the things we talk about sometimes is finding the right balance within NASA of human and scientific. But it's not just that. I mean, we don't want to just keep them too separate, because what we want to do is make one inform the other and make them both complementary. And that's what we're seeing with the Mars program. And I think one of the things we're going to talk about later is the greenhouse on Mars, or one of the proposed instruments on the next Mars rover, which is actually supplied by the human side of the space program to kind of advance, technologies they're going to need for sustaining human pioneering on the surface of Mars. And so we want to kind of maintain, I think, a healthy balance. The society in the past is usually, as a rule of thumb, about a third of NASA should go to science. Right now it's about 28%. Third of NASA going to science, the rest for running NASA, building rockets, maintaining space station, and the next generation of human exploration. I think that's pretty healthy. But we haven't quite worked out the exact level of that.
Well, I look forward to this passing and becoming law, as opposed to being pulled away from the stall at the last minute.
So that's the other thing. So I should say, everyone who's excited about this, like I am, we need to remember, as you said, this is not law yet. It's out of the House committee. It's past the committee in the House. It's a really important hurdle. It goes to the full House for a vote sometime in the next few months. It probably is going to pass there. Again, the Senate needs to do their thing, and the whole package needs to get voted on. So if you haven't written your representatives yet, if you haven't called them yet, if you haven't been involved yet, you still need to do that, because they need to know that support is there to continue this fight to get this funding through and into law for NASA. And that's to say, you can go to planetary.org/SOS. You can use any other way to contact your representatives you want, but we make it easy for you. But again, we're not done yet.
All right.
So this is a great piece of good news, and we need to make sure that it gets through.
All right, well, let's move on. let's go with, and speaking of things that are happening that people are organizing, Scott Lewis, why don't you talk about your One Sky event?
Oh, so, gosh, like 2 weeks ago, I just crossed paths with another awesome person on the internet, Henna Khan out of India, out of Mumbai, and she was just organizing a group of people in India to go outside and look up. And so we talked a little bit and decided that we wanted to make it a little bit larger than that. And so we're contacting countries from all over the place. So we have India, we have Pakistan, we have Japan, El Salvador, UK, US, all over the place, that people are just going outside today, and I guess part of yesterday, depending on where you're at in the world, for the 9th of May, just to look up and share the night sky as a group of human citizens. That, we have a lot of things between us, and a lot of things that are both physically between us, socially between us, but we all are able to transcend that in the name of just the love of where we are in the universe and what we can observe in it. And the hashtag we've been using is just One Sky, and the pictures are phenomenal. So especially on Twitter, where I'm seeing a lot of them coming up, it's just the hashtag One Sky with no space between it. But we also have events on Facebook and Google+, so there's no preferred network for people to go to so they can find it wherever they want. But I know Henna just finished up in India a little while ago, and they had a few hundred people out there at her one event, and there were 6 events in Mumbai itself. And so I'm starting to get those pictures in. We'll be creating a wrap-up video earlier next week. And tonight, if you're in the Los Angeles area, I'll be up at Griffith Observatory with some friends that are in town. Sophia is in town from York University in Toronto. A friend Alberto Conti from Northrop Grumman is going to be visiting as well. And we're just going to be up there hanging out. I'll have my Celestron binoculars, taking a lot of photos, and just trying to reflect on the fact that we have enough to fight about. We can just go out there and look up and appreciate the phenomenal beauty and what we can learn about ourselves just by learning about the universe.
Sounds great. I don't know how much you'll be able to see from LA. What do you can see? The moon?
The moon. Well, that's why I'm bringing the binoculars.
Yeah, the moon. Maybe Mars and Saturn a little later.
See the moon.
Right. So
Jupiter briefly.
Right. So
and Mercury. Best night for Mercury.
Yeah.
So you should be able to see it. No problem.
If you want more details, because we have all of the official public events that you can go to. So it's all throughout North America still, and also I believe in the UK. Yes, UK is still able. Go to knowthecosmos.com/onesky. We have a list of all the countries involved with Google Map links to the public events that are free to anybody to join. So go ahead and click on that, and it's
awesome.
free.
Okay, cool. All right, so let's move on. So Casey, you've been following the SpaceX launch, and we had talked last week that it was going to launch, today, tomorrow, but it's been scrubbed, right?
Yeah, they were doing a test fire of their engines today for an anticipated launch tomorrow of a bunch of Orbcomm communication satellites, one of their commercial payload deliveries. And there was a problem. NASA Spaceflight's got the details on this, nasaspaceflight.com. There was a leak in one of the engines, or I'm sorry, somewhere again. I have a little vague on exactly where the leak was, but they do have to delay the launch. They say right now too late May. There's some issues with working out. It's a busy launch season right now down at Cape Canaveral, and so they have to kind of wait for a few other launches for the DoD, and I think DoD launches the next couple of weeks. So they're slotted in for late May. They have to bring the whole rocket back into the facilities and repair the leak, get everything back together and test. So it's going to be a little bit before we see another SpaceX launch.
But the goal here was hopefully to see another firing of this attempt to soft land the bottom stage, and hopefully this time around we would get some legit video footage of the landing as opposed to that awful one frame that we had last time. So
right. So we'll just have to wait a little longer for that, unfortunately. It's rocket science. I've heard it's a little difficult.
A little difficult, yeah. All right, cool. So Morgan, you watched Cosmos.
I did watch Cosmos, and this was a very good episode of Cosmos. I hear tell that you also watched Cosmos. That's
I did, and I
activity.
really enjoyed it.
And this
Yeah,
is
this
the one
one-
week I didn't, and now I'm going to have to suffer through spoilers.
All right. Spoiler alert: space is awesome.
Yeah, so this one reminded me a lot of episode 2, which was when they addressed evolution by natural selection. And the parallels were more than just structural because they, once again were tackling a major social issue of our time, in this case, climate change. And they've kind of been dancing around climate change over the last few weeks and, sort of jabbing here and there, but they never really came out and addressed it head on until this Sunday, I'm sorry. And, just like with evolution, they came out, unequivocally against people who are denying the existence of climate change and laid out, some of the comprehensive evidence that we have for climate change here on the Earth and what the effects of that climate change could be if left unchecked.
Dragonflies as big as eagles, and
If
millipedes.
that doesn't get you scared, I don't know what will.
Millipedes as big as, what was it, dogs, horses? Big millipedes.
Wow.
Yeah, that's what you get. That'd be all right.
I want, you know what? As a commuter in Los Angeles, I could go for one of those.
Yeah, for like a big millipede.
Yeah, just ride.
Ride a millipede.
Yeah, drive a millipede.
On Pacific Coast Highway, on my giant millipede.
Yeah, but what was great was the way they explained sort of why you got those big insects in the past, because the oxygen levels were richer and the insects could draw in the oxygen more easily than they can today, and so it supported larger insect sizes. So that was fantastic.
Like Bosch's Garden of Earthly Delights, for all the sin of using carbon. Now we have like giant monstrous creatures devouring us all as a consequence of it.
Yeah. Yeah, and then as you mentioned, like with the climate change and the sort of, they go into this idea of the halls of extinction, and like there's the Cretaceous and there's the Jurassic and and then here is the next one for you.
Right. Up till now,
Wow.
extinctions have basically been out of the control of the creatures that were dying. Whether that's, enormous volcanoes polluting the Earth's atmosphere or, killer asteroids striking the Earth. There's nothing, even if we'd been around, there's nothing that we could have done about those. And the question is, now faced with something we can control, how unconscionable is it to not take action to save not only ourselves but untold number of species out there in the world from a fifth-grade extinction.
So needless to say, the climate change deniers went berserk on the Twitters. I actually tracked the Cosmos. I tracked the Cosmos hashtag and also all of the sort of after the show, and it's just hilarious.
Were there any funny branch-off hashtags? Because I've seen those too, and they're hilarious.
Really? Yeah. So we got that with the evolution one, and this was a very controversial episode. Like, if you have a problem with climate change, then people really got mad about it.
Yeah, some people thought, it didn't.
Well, it
wasn't appropriate for, this venue, and I got comments on my site saying, "Hey, I wish you would only write about astronomy and space science."
Oh, you'll get a million of those.
Yeah. Well, and the bottom line is that, climate change is the story of the solar system. Whether it's Venus or Earth or Mars or Europa, changing climate has driven the evolution of every surface in the solar system. And so it would be naive of us or short-sighted of us to study the climate change of every other body. I mean, MAVEN is on its way to Mars right now to study climate change at Mars. This is, a global scientific issue, and it would be silly just to ignore the Earth in that setup.
Because it's not a planet.
Well, you also had this week the release of the U.S. National Climate Change Assessment Report, which was just very well timed to go with that Cosmos,
Yes.
which, I don't know if you read it, but has a few kind of like terrifying things of its own to talk about how it's happening right now. And again, you see the predictable response. I think today Charles Krauthammer in the Washington Post had this pseudo-intellectual attempt to define away climate change from happening, but of course, as usual, riddled with inconsistencies and strawman arguments. And again, it is kind of fascinating to see the argument against climate change being like, no, it's not happening. Let's pretend it's not, and it'll just go away, and we'll be fine. And not even not to deal with it, but not even to study it. And that kind of goes to the essence of the problem, which is where the two sides are, this is happening, we need to do something about it, and then not just denying it exists, but denying even looking into understanding how climate changes. That's a terrifying gap that's grown in the last 10 years, and a really, really unfortunate one, because the New York Times just had a story about how Miami is already starting to get flooded a little bit by rising sea levels, and we're going to have massive impacts here in the next 50 years, and by merely denying it, we're all kind of dooming ourselves to suffering those consequences.
Yeah, droughts and wildfires and flooding and rainstorms and all of that. I mean, it's just, yeah.
Well, and suddenly studying these complex systems is important not only within our solar system, but with the Kepler mission. We just announced Kepler 186f, that there is this Earth-sized planet in the habitable zone, but what depends on that being anything viable for life is an atmosphere, the climate that's on it, what it's able to do, what we're able to learn about other planets throughout our galaxy depends on our understanding of how climate works and what is contributing to the changes of it. If we're going to pretend like it's not happening here, but we can see what happened on Venus, and it must have been those really, really bad Venusians that caused that to happen, but that never happened on Earth. It's just natural, it's just going to go back. Yeah, it might go back, but we might cause ourselves to go extinct first.
Yeah. How quickly can we change with it is the fundamental question.
Yeah, and again, I mean, with all the new technology that's coming out, solar power is decreasing now as part. It's a silicon chip problem. It's following Moore's law. The prices from solar power, the decrease of use of power from LEDs, all these kinds of stuff, and all this new technology that's coming online that needs that scientific breakthrough that's going to come out of these countries. It's all mixed together, the need with the kind of need for the U.S. and Canada and all these countries to boost their science efforts and all that. It's amazing to me that anybody doesn't just go, like, even the people who don't believe in climate change would just be like, well, yeah, it'd be good to not be burning oil, so let's have more science. So,
as a person who lives in Los Angeles around more cars than people, I would love for all cars not to burn gas.
Yes, great.
Yeah, it's like a bunch of Tesla.
I don't really like the feeling.
I enjoy it when the sky is not literally purple or green on my skyline.
Right.
I'm not exaggerating. It's what I see.
Yeah, I love it when I swapped out a whole pile of lights into LED lights in the house, and you could see the difference on the amount of power usage. So anyway,
money. Yeah.
All right, let's move on.
Well, I'm good. We agree with each other, guys.
Yeah.
Everybody, we all agree.
Group hug.
So I mean, Morgan, do you think that the cosmos is a little heavy-handed with the way they're sort of almost antagonizing the anti-science, pro-creation, not procreation, but pro-creationist, the anti-evolution, all of those, I mean, they really are kind of going out and bopping the various enemies of science on the nose.
Fraser, talking about scientific realities isn't antagonistic. They haven't gone out of their way to, draw these people out by name and pick on them. It would be unfortunate if a show about science couldn't talk about the broad spectrum of science. And I think that they've spent, this hasn't been 12 episodes on evolution and climate change. It's been 2. And it's been mixed in as, interesting scientific discoveries along with all of the other amazing scientific discoveries that they've talked about so far. And I don't think that they've highlighted this above and beyond, the discovery of relativity or the spectrum of light. Things like that have been just as emphasized as things like climate change. It's just that we're more sensitive to climate change and evolution because for some reason people don't accept those while accepting all of these equally supported topics, or even in some cases far less supported topics that we talk about in space all the time.
Well, I think though that a pushback against anti-science is a theme of this show, and it's I think, more than just like here's all the science, but actually, no, here's all the science, and also anti-science is bad. And
Well,
I mean, obviously, I agree that anti-science is bad. I'm more, preaching to the choir here, but I think it's I'm glad they took that direction, and I'm glad that people are getting angry about it.
To me, it makes sense. I mean, Neil's known for saying, the best thing about science is that it works whether you believe it or not. Yeah. And that's really what this is saying here. So you don't have to philosophically or intellectually agree with this, but that's not the deficit of science. That's the deficit of your understanding, or maybe some outreach has not been done enough in a way for you to be convinced of what's going on. But it doesn't make it any less true just because you don't quite understand it yet. Yeah. And that just gives outreach, SciComm and outreach personnel to up their game and find better ways of convincing the public that might not understand or might vehemently be opposed to something that has a lot of evidence for. We just need to find better ways to convince.
All right, let's move on. Let's see. So we got one other story here from Morgan about sending plants to Mars.
That's right. So I think it would be fair to say that NASA's overarching goal these days is to get people to Mars. And we're working towards that, as Casey alluded to, in the manned spaceflight program with things like the Orion capsule and the Space Launch System, building new rockets and new habitats for the trip to Mars. And we're doing this in the scientific side of things with things like Spirit and Opportunity and Curiosity, looking to understand the surface chemistry, the atmospheric chemistry of Mars better. And as we move forward, that's going to be less an emphasis on was there life there in the past and more an emphasis on, what is there today that we can utilize to work and live and thrive on Mars. And one of the things that people need is food. And for the International Space Station, we send, SpaceX rockets and Soyuz capsules and things like that up to the space station on a regular basis to send them, astronaut ice cream and things like that. But that's not a sustainable method for feeding people on another planet. We might be able to send the first wave of explorers with enough food to last the trip. But if we really want to set up shop there and do long-term science, we have to be able to feed ourselves. And the easiest way to feed ourselves is to grow our own food. And so we've been working on this at the space station. The space station has experimented with growing plants and things like that. But Mars is a different environment even than the space station. It's not protected by the Earth's magnetic field nearly to the same extent that the ISS is. And so we don't really yet know how this strange gravity and high radiation might affect the development of plants. And so the first step that NASA is thinking about taking, and this is just a proposal at this point, is basically to place a mini little greenhouse on the next Mars rover. This next Mars rover is slated to launch in 2020. It's looking like it's probably going to be kind of a sister rover to Curiosity, a similar design, maybe with some different instruments. And in addition to those instruments, on the top would be glued this kind of bread box size plexiglass box filled with dirt and seeds. And those would hang out there during the space flight from Earth to Mars, and then when the rover lands on Mars sometime in 2021, a sprinkler goes off and wets that soil, and over the course of a few weeks, those seeds will sprout and they will grow. And then Curiosity can use its cameras and things, as well as any sensors built into that box to measure how well those plants are growing. And it does this.
Morgan, do you have any sense?
Yeah, go ahead.
Do you have any sense how this interferes or impacts the planetary protection, which is all about not sending alive things along with rovers to Mars? Because that seems like a real interesting problem.
It is, and so they've highlighted this box idea as being a solution to that problem, as opposed to digging a hole and tossing seeds
planting
into,
a bunch of
farming Mars. But it's a definite question, because if something were to go wrong with the landing process, whether that's breaking into the atmosphere, parachuting down, sky craning from there, you'd have to design this in such a way that it could survive an impact and maintain its integrity. And yet it also has to be transparent enough to let sunlight in so that plants can grow. And Casey, I expect that this is probably one of the major bumps that they're going to have to overcome, is convincing the Planetary Protection Officer at NASA that they can do this in a way that is highly reliable. And I don't know how you go about doing that and still, make it light enough and inexpensive enough to just tack on to an existing design.
Just have the rover detonate.
Yeah, interesting problem.
Take its plutonium pile and somehow make it a nuclear weapon as well.
So we have experience with building parts of spacecraft in order to survive impact, because every time we launch a spacecraft with some sort of radioactive source on it, like Curiosity or Cassini, those have to be designed so that if the rocket blows up in mid-flight, it lands in the ocean and doesn't, disperse radioactive material. And that's happened, and they've performed as we expected. But you generally do that by encasing them in steel and titanium and all of these very heavy and very opaque substances. And how to do that in a lightweight and transparent, physically transparent way is going to be a big engineering challenge. But we have to do it in order to, take the next steps.
Well, I mean, a lot of the ideas for colonizing Mars really depend. Yeah, transparent aluminum. I was going to think of the same thing. A lot of these ideas of actually sending humans to Mars to live there depend on people being able to provide their own food via, getting local water and getting the local regolith and removing the perchlorates and actually trying to grow some food in this soil. But what if something about Mars, the low gravity, just makes it not work? I know we've grown plants in zero gravity, but have we grown 10 years worth of plants in zero gravity? I mean, is there some process that zero gravity is just going to make it that you're going to have to essentially evolve? You're going to have to, you're going to have to grow plants generation after generation for 10 years, 20 years until you've got a viable kind of plant that can handle that low gravity. So these are these big questions that we don't even know, and yet everyone's like, don't worry, when we get to Mars, we're going to just, take our tomato plants, we're going to plant them in the ground, and we're laughing. But we don't know. I mean, we don't even know, we know that zero gravity is completely toxic to our bones and our muscles, and you can prevent it for a little while using exercise. But we don't know what will happen over 10 years, 15 years, 20 years, if it's even possible for the human body to survive, even if they're out running on their Colbert treadmill every day. And
right.
So this is, I think this is a really important question to answer.
Well, this is NASA's argument for, stepping up to Mars slowly.
This is sustainability.
We've been studying human habitation outside of the Earth in the ISS for 15 years now. And then we're going to go and study, an asteroid and how people can survive and work in these environments and do geology, because that's what we're ultimately going to want to do at Mars. And then, we send the first people to Mars, and we stick around for a little while. We maybe bring our own food. We figure out, what is the surface really like for people. And then, and only then, I think, will we feel comfortable in saying, well, we've built up the technologies necessary to enable long-term habitation of the surface. And, I think that's decades away, and it's rightfully decades away, because we want to do it in a way that's safe for people. We want to do it in a way that's scientifically productive. And history has shown us that, it takes 10 years just to develop the technology to fly to the moon and walk around for a couple of days, much less, try to camp out there and live.
I'd like to see them send mice. So send mice with the plants and then see whether the mice can survive on the plants that are growing, and that
I'm just getting visions of a new video game. Instead of Harvest Moon, it's just going to be Harvest Mars.
Harvest Mars.
I like this.
Yeah.
But it's something that it's a feat. It's something we have to do, and you have to take first steps anywhere to get there.
And the only way to figure out how to do it is to do it and fail.
And to fail at it and do it better next time.
Yeah.
I mean, you're not going to have phenomenal success the first time. You have to see what works and what doesn't and learn from that.
But wouldn't it be heartbreaking if life just, like Earth evolved life, just can't handle the low gravity of Mars?
It would be heartbreaking, but I think it's probably pretty unlikely. Life has demonstrated on Earth how hardy it is, and I would think that gravity would probably be one of the least difficult things for plants to overcome. I mean, that if anything, that might make them more successful, able to grow larger and stranger. You don't have you
Yeah.
make the joke about planting tomatoes on the surface of Mars, but I think a tomato plant would probably stand up a whole lot better on Mars than it would here on Earth, where you have to prop them up with sticks and
Yeah, no tomato
ladders
cages.
and
Wait a
things.
minute.
And, it could Mars could become our next breadbasket.
That's true.
In
All right, cool.
50
Well,
years.
so I think we got one last cool image, Scott, of
Let me pull it up.
of Earthrise, the latest version.
So this is from the Lunar Reconnaissance Orbiter, which it's been almost up there for 5 years now. It was June of 2009 when it launched, and it's out there mapping the surface of the moon. So it's rarely looking around doing anything else. But they did pitch it up, and it got this amazing view of our planet. Let me see if that pops up there. There we go. I zoomed in a bit because it is a bit of a tiny picture, but the image we're seeing here is the brightness is actually correct compared to the surface of the moon to the Earth. So the Earth is much brighter, as we can see. The albedo is much higher, but and then the color is a color composite. So it's not completely accurate, but it's been calibrated to what it would look like from the human eye. So this amazing mission that's been out there just doing super detailed images of the lunar surface just peeked up a little bit to take a look as it was going over the pole. And there's also another animated GIF here that I'm going to share out. Again, tiny, so I had to zoom and enhance a bit. I'll try to put it into the event page, but it's a blind. So we're seeing here on the bottom the movement of the moon behind it while we're seeing the Earth rise. And
That's really cool.
I love it.
Has anyone stitched that into a proper animation video?
I will do my best to get the raws, because you know how I am with.
I know. This is this smells viral to me.
Yeah, so I will do my best to get the raw images and put something together that looks less like you're peeking through the blinds, like your private eye.
Yeah.
But
That's cool.
I just love that it just shows our imagination as as a species. We're finding new ways of using our different scientific instruments, whether it be Hubble with frontier fears like we were talking about earlier, or even using the Lunar Reconnaissance Orbiter to grab a sneak peek of our planet, of home. Same thing like we did with Voyager, just turning it around and getting a snapshot of home, and where we get pale blue dot out of. It's just the way that we're able to remind ourselves where we're coming from and why we're doing this at all.
Renko Prozo wants to know if anyone's going to Space Fest this weekend.
I'm not.
Amy Shearer title's there.
Amy is there. She just texted me. She's going to be hanging out with me for a bit, but I don't know who else is. I know Ian's not. Ian had to back out.
Where is it located? Is it in
Pasadena? Are you there, Casey? I know Emily is.
I'm not on the schedule. Emily's speaking today, and we had a planetary radio show there last night. I'm not sure if I'm going to stop by because I have a lot of things to catch up on.
Right.
So Michael Jobin notes that we'll get a gamma ray mutant Hulk plants on Mars. And that's true, because it will be lots of gamma radiation pouring down on these poor plants.
We wouldn't like those turnips when they're angry.
Yeah. I don't think gamma radiation will affect them in the way we would be hoping. Mostly the bad way. Man, there's so many. Everyone has been so busy in the Q&A. So Tom Nathy notes that Mars has a toxic, sterile soil, doubtful that Earth plants would grow directly without external help. So that's exactly right. There's I know this is probably, you know more about this, Morgan. There's perchlorates in the top layer of the Martian soil, which...
That's right. Those are very harsh salts, and as we know here on the Earth, salt is not so good for growing things. But there's a couple of ways around this. We could bring sufficient Earth material to sort of start the first generation of plants going, and then use their dead bodies basically to farm the next generation. We could look to grow plants in hydroponic type situations, and we have experience growing hydroponics here on the Earth. But we also have the opportunity to work with things like genetically modified or genetically engineered plants and animals. And I know that's kind of a touchy subject with people here on the Earth, but when we're going to another planet, we need to help the things that we're hoping to grow there adapt to that planet, whether that's the atmospheric composition or the surface composition. And I imagine that just like we've been able to grow drought-resistant corn here on the Earth, we'd be able to develop plants that were hardier towards the Martian environment going forward.
All right, well, let's wrap things up then. Casey, where do we find out more about both you
go to
and your work with the Planetary Society?
Oh, sorry, too eager. Planetary.org for the main website, planetary.org/SOS for all of the details about politics, policy, and what you can do to help change NASA for the better.
What is the SOS? Save our space?
Save our science.
Save Our Science.
Science.
Originally, I'm working on a new title. Yeah, Save Our Science, but SOS is easy to remember, or just go onto the homepage. I'm linked to from there, and also on @ExplorePlanets on Twitter.
Cool. All right. Morgan, where do we find out more?
Yeah, that's right. You can find me at cosmicchatter.org, and you can follow me on Twitter at Morgan Rehnberg.
Right on. And Scott, people can find you at @ScientificScott. And one more plug for One Sky.
One Sky, so just use the hashtag One Sky. If you want to find any local events in your area, go to knowthecosmos.com/OneSky. And you can find me everywhere on the internet. Virtual Star Party, Space Fan News, Deep Astronomy, all the stuff. All the science space things.
And you edited our latest episode of the Guide to Space.
Yeah, I did.
It was great. Thank you very much. And you've, I think, got the next one. At warp speed, you got the next one. So thanks a lot for that. So once again, I'm Fraser Cain, publisher of Universe Today. You can see all of the news that we're publishing at universetoday.com. And if you haven't already, subscribe to this YouTube channel, wherever you're seeing it. And if you don't like your news live, then you can also get the podcast edition of this. You can just do a search on iTunes, and you can subscribe to the audio and the video versions of the Weekly Space Hangout. So, well, thanks everyone for watching, and I guess next thing we're doing is going to be the Virtual Star Party on Sunday night. If you still have any interest
send
in
your climate change hate mail to
Scott.
Fraser at Universe Today. Just FYI, everyone watching.
Yeah.
No, I'll take it. I have a special pile.
I have a special
Fraser
list. I put the change hate mail.
I
Yeah.
have this great inbox called a trash can, and it just
Exactly.
boom.
All right. All right. Thanks everyone. We'll see you all later.
Hi everyone.